There is a walk in the woods that changed everything. Not a dramatic moment, not a lab, not a chalkboard covered in equations. A father and a small boy moving through trees, and a father pointing at a bird. Melville Feynman had no formal scientific training. He sold uniforms for a living. But he had something rarer than a degree. He had a genuine, almost desperate need to understand how things actually worked beneath their surface. And before his son Richard could even read, Melville had already decided what kind of mind he was going to build. So they walked, and Melville pointed. And he asked his son, "Do you know what that bird is?" And then he answered his own question in a way that Richard Feynman would carry for the rest of his life, and would repeat to students and journalists and anyone who would listen for the next 60 years. See that bird? It's a brown-throated thrush, but in Germany, it's called a Halsenvogel, and in Chinese, they call it a chungling. You can know the name of that bird in all the languages of the world, but when you're finished, you'll know absolutely nothing whatever about the bird. You'll only know about humans in different places and what they call the bird. I want you to sit with that for a second. Because what Melville Feynman handed his son in that moment was not a fact. It was an entire philosophy, a way of moving through the world, a filter for sorting real knowledge from the performance of knowledge. And it is, I think, one of the most valuable things one person has ever given another. Names are not understanding. Derivation is understanding. This sounds simple. It is not simple. Because most of what we call education, most of what we call expertise, is built almost entirely on names, on terminology, on the ability to use the right word at the right time in front of the right people. And what Melville Feynman said to his boy in those woods was, "That is not enough. That will never be enough. If you cannot explain what the thing actually does, how it actually works, what would happen if you changed one variable? You do not understand it. You have merely been introduced to it." Richard Feynman spent his entire life refusing to be merely introduced to things. And so this is where I want to start. Not at Los Alamos, not at the Nobel Prize ceremony in Stockholm, not at the Challenger hearing room where he dropped a rubber O-ring into a glass of ice water and broke through months of institutional lies with a single clear experiment. I want to start here, in Queens, New York, in the early 1920s, with a father who sold uniforms and a boy who was learning, before he could articulate it, the single distinction that would define him. James Gleick, who wrote what I consider the definitive biography of Feynman, simply called Genius, understood this immediately. The walks with Melville weren't supplementary to Feynman's education. They were the foundation of it. Everything else was built on top of this one idea: the difference between knowing the name of something and actually knowing something. And here's what makes this so powerful when you think about it in the context of a life. Feynman would go on to become one of the most celebrated physicists of the 20th century. He would reformulate quantum electrodynamics in a way that nobody else had managed. He would invent an entirely new visual language for particle physics that is still used today. He would win the Nobel Prize. But he never once stopped applying his father's test to his own work. He applied it to himself most of all. That is what is unusual. That is what is rare. Most people, when they achieve mastery in a field, begin to lean on the authority that mastery gives them. They stop rederiving. They stop questioning. They allow the name of what they know to substitute for the knowledge itself. Feynman never did this. He could not. His father had made it impossible. And what you get when you build a mind this way, when the foundation is not memorization but genuine derivation, not authority but honest inquiry, what you get is a person who is genuinely free inside their own thinking. Feynman could encounter any problem, in any field, and approach it as if from the beginning. Because for him, everything began from the beginning. Every time. He said it himself. Physics was not his subject. Understanding was his subject. Physics was just the arena. A father and a boy. A bird in the trees. A name, and then the truth behind the name. That is where Richard Feynman starts. And honestly, once you see it, once you really see what Melville gave him, everything else that follows makes complete sense. So the father planted the seed, and now the boy has to grow it himself. That is what Section 2 is really about. Not a classroom, not a mentor handing him the answers. A kid in Queens, in a bedroom converted into a laboratory, figuring it out piece by piece on his own terms. Feynman grew up in Far Rockaway, which is about as far from the gleaming corridors of theoretical physics as you can get and still be in New York City. Working class neighborhood, modest house. And in his bedroom, wires, batteries, resistors, a hand-lettered sign on the door that read, Richard Feynman, radio repairman. He was roughly 12 years old. Think about what that actually means. Not 12 and already accepted to a gifted program. Not 12 and being groomed by some prestigious institution. 12 and already building a business, if you can call it that, out of pure self-directed understanding. Neighbors would bring him broken radios. He would fix them, not because he had been trained, because he had reasoned through how they worked. And the way he fixed them is the thing. He would sit quietly before touching anything, just sit there and think. What could be causing this behavior? What would I expect to see if it were this problem versus that one? Then he would look. Then he would fix it. Neighbors thought it was strange, this boy who sits still before he does anything. But that stillness was the whole method. He was already deriving before acting. This is the work ethic, and it never left him. It wasn't about hours. It wasn't about grinding through problem sets. It was about this absolute refusal to borrow an answer he hadn't earned himself. At MIT, where he went after Columbia rejected him, reportedly due to Jewish enrollment quotas, which is worth sitting with for a moment, he developed a reputation among his professors for solving problems by routes that nobody recognized. His notation was different. His methods were different. Not because he was being eccentric, because he had derived everything from scratch and arrived at his own roads to the same destinations. He distrusted memorized formulas the way his father distrusted bird names. A formula you've memorized is just another name. A formula you've derived that you could rederive right now if someone erased it. That is something you actually possess. And then there was Princeton. And then Los Alamos. And somewhere inside all of that, this quality expressed itself in the most Feynman way imaginable. The Manhattan Project. The most classified collection of scientific secrets ever assembled in one place. Senior scientists with combination safes full of documents that could not, under any circumstances, fall into the wrong hands. Feynman spent considerable energy cracking every single one of them. His method was exactly what you would expect. He observed that people set combinations to meaningful numbers, birthdays, mathematical constants they admired. He studied the mechanical tolerances of the safe models being used. He tested, he reasoned, he cracked them. And then he left notes inside. I borrowed document number LA4312, Feynman the Safecracker. This drove the security officers absolutely insane. But look at what it actually was. It was not a prank in the way a bored person plays a prank. It was a demonstration. Security built on the assumption that no one would probe it is not security. Feynman could not encounter a closed system, a lock, a formula, an institution, an argument, without needing to open it and understand what was inside. That is the whole man, right there, at age 23, leaving notes in government safes. But here's the thing about all this self-reliance, this ferocious independence of mind. It had a cost. After Arlene died in 1945, and after the bomb fell, Feynman arrived at Cornell as a professor and found that the engine had gone quiet. The curiosity was still there, theoretically, but he couldn't feel it anymore. He sat down to do physics, and nothing came. He later described believing that he had burned himself out, that Los Alamos had taken the best of him. He was not yet 30 years old. And then, a cafeteria. Someone tossing a dinner plate in the air, the plate wobbling as it spun, the Cornell medallion on it tracing that particular elliptical shimmer. And Feynman, for no reason, with no application in mind and no career incentive whatsoever, started working out the mathematics of the wobble. He describes it himself, and I want you to hear this in his own words, because this is one of the most important sentences in the history of how creative people work. I had nothing to do, so I started to play. The diagrams and the whole business that I got the Nobel Prize for came from that piddling around with the wobbling plate. Piddling around. That is what the Nobel Prize in Physics came from. Not a prestigious grant, not a targeted research program. A man in a cafeteria, finally free of obligation, following his curiosity the way his father taught him to follow the bird. Past the name, past the category, into the actual thing. Columbia didn't want him. It didn't matter. No institution shaped him, because he had already learned the only lesson that counted. In the woods with his father, in the bedroom with the radios, in the silence before touching the broken thing. You do not understand something until you have built it yourself, from nothing, in your own mind. That was the education. That was always the education. So here is Feynman, sitting at Cornell. The war is over. Arlene is gone. The bomb has been built and dropped, and he was there for all of it. And now he is supposed to be one of the great rising physicists of his generation, with a faculty position at one of the finest universities in the world. And he feels nothing. He later described this period as a kind of paralysis. The work that had once felt urgent, the Manhattan Project, the pressure of wartime, the sense that physics mattered right now, all of that was gone. And what replaced it was a creeping, suffocating doubt. He started to wonder whether he had already done everything he was capable of doing, whether the best of him was already behind him. And then, one afternoon in the Cornell cafeteria, someone tossed a plate in the air. Just a dinner plate, spinning, wobbling as it spun. Feynman watched it. He noticed that the wobble and the spin were happening at different rates, and something turned on inside him. Not ambition, not purpose, just pure, uncontrollable curiosity. He wanted to know why. He started working out the mathematics of the wobble right there, for no reason at all. No application, no grant, no paper in mind. Just a wobbling plate, and a man who could not let a thing remain unexplained. He said it himself. This is one of my favorite things he ever said about his own work. I had nothing to do, so I started to play. The diagrams and the whole business that I got the Nobel Prize for came from that piddling around with the wobbling plate. I love this so much. The Nobel Prize in Physics. 17 years of subsequent work that rewrote quantum electrodynamics. All of it. All of it. Traced back to an afternoon of playing with a spinning plate in a cafeteria because it looked interesting. Because the wobble had a reason, and he needed to know what it was. And this was not an accident of circumstance. This was a philosophy. A deeply held, almost religious conviction about how the best work actually gets done. Feynman believed, and I mean believed it the way other people believe in things they would die for, that the joy of discovery was not a side effect of doing good science. It was the source of it. He had watched himself try to work from obligation, from reputation, from the pressure of being Richard Feynman. It produced nothing. And then he gave himself permission to play, with zero justification, and everything poured out of him. The path integral formulation, the Feynman diagrams, the visualization of particle interactions that would make quantum mechanics legible to physicists for generations. All of it started with play. He said that the prize, the Nobel Prize itself, was almost beside the point. His words, "The prize is the pleasure of finding the thing out, the kick in the discovery, the observation that other people use it. Those are the real things. The honors are unreal to me." He meant that. He was not performing humility. He had genuinely felt the experience of discovery, and he knew that no medal could compete with it. There is a BBC interview from 1981 called "The Pleasure of Finding Things Out." It is one of the most extraordinary hours of footage I have ever seen. Feynman sits there, relaxed, funny, and he explains what it actually feels like from the inside to be a curious person. And he says something that has stayed with me. He says, "I can live with doubt and uncertainty and not knowing. I think it's much more interesting to live not knowing than to have answers which might be wrong."
Think about what that requires. Most people find uncertainty unbearable. We reach for the nearest available explanation just to make the discomfort stop. Feynman was the opposite. Uncertainty was not something he tolerated, it was something he savored. Because uncertainty meant there was still something left to figure out. And he extended this into what he believed science fundamentally was. He told the National Science Teachers Association in 1966, "Science is the belief in the ignorance of experts." That is a radical statement. He was not being provocative for effect. He was describing the actual engine of progress, which is the willingness to say that what we currently believe might be wrong, and that the person who finds out it is wrong has done something sacred, not something disloyal. He also believed, and this connects directly to everything his father gave him in the woods, that this kind of understanding, this deep, derivational understanding, does not flatten the world. It expands it. He talks about a friend who was an artist, who told him that scientists take a flower apart and make it dull. And Feynman says, "I think that he's kind of nutty. The science knowledge only adds to the excitement, the mystery, and the awe of a flower." That is the thing. That is the whole thing. The beauty of understanding is not that it replaces wonder, it is that it multiplies wonder. Every layer you pull back reveals 3 more layers beneath it. The plate wobbles. You work out why, and now the plate is more interesting than it was before, not less. Understanding is not the end of awe, it is the beginning of a deeper one. That was the gift his father gave him in the woods. That was what the radios in Queens were training him for. That was what the wobbling plate unlocked. Not a Nobel Prize. A way of being alive in the world that made everything, every spinning thing, every moving thing, every broken thing, endlessly, permanently worth figuring out. There is a moment in that BBC interview, 1981, Feynman sitting across from Christopher Sykes, completely at ease, where he says something that stops you cold. He's talking about a friend who is an artist, and this artist holds up a flower and tells Feynman that a scientist like him can only ruin a thing like this, that by taking it apart, by reducing it to pigments and photons and cellular mechanics, you drain it of its wonder. And Feynman listens, and then he says, "I think that he's kind of nutty." I love that. I love that so much. But then he goes further, and this is where it gets serious. He says, "The science knowledge only adds to the excitement, the mystery, and the awe of a flower. Not replaces it, adds to it. That is the whole argument. That is everything. Understanding does not murder beauty. Understanding is the deepest form of beauty available to a human being." And Feynman spent his entire life trying to prove that. Not in papers, in the way he moved through the world. He genuinely believed that most people had been sold a lie, that curiosity and wonder are childlike things you outgrow when serious knowledge arrives. He thought that had it exactly backwards. The more precisely you understand something, the more there is to be astonished by.
The flower is not diminished by knowing how its pigments absorb light. The flower becomes a window into quantum mechanics, into evolution, into the unimaginable complexity of what it took for that particular arrangement of matter to exist and to be seen. That is not a smaller experience than what the artist had. That is a much, much larger one.
And so Feynman had a problem, because everywhere he looked, he saw people settling for the name of the flower instead of the flower itself. And that bothered him deeply. Not as an intellectual preference, as a moral issue. In 1974, he stood at a Caltech commencement and delivered what I think is one of the most important speeches ever given. He called it cargo cult science. And the idea is this. During World War II, isolated Pacific Islanders watched Allied planes land and bring extraordinary cargo, food, tools, materials beyond anything they had seen. After the war, the planes stopped coming. So the islanders built runways out of wood. They fashioned headphones from coconuts. They lit fires along the airstrips at night. They did everything a real airfield does, and they waited. The planes never came. Because the form was there, the substance was not. Feynman looked at a great deal of what passed for scientific inquiry and saw the same thing. The language of science, the apparatus of science, the social rituals of science, without the one thing that makes it real. He called that one thing utter honesty. And he said, "There is one feature I notice that is generally missing in cargo cult science. It's a kind of scientific integrity, a principle of scientific thought that corresponds to a kind of utter honesty, a kind of leaning over backwards." Leaning over backwards. That phrase is precise. He means you must work actively against your own desire to be right. You must search for the ways you might be wrong. You must report everything. Not just the evidence that confirms your conclusion, but every inconvenient anomaly, every stubborn data point that doesn't fit. Because if you don't, you are not doing science. You are performing it. And then he said the line that I keep coming back to, the one that applies so far beyond physics it almost hurts. The first principle is that you must not fool yourself, and you are the easiest person to fool. That's it. That's the whole thing. You are the easiest person to fool, because you already want to believe what you believe, because your reputation is tied to your conclusions, because uncertainty is uncomfortable and a clean answer, even a wrong one, feels like relief. Feynman refused that relief his entire life. He described this not as discipline, but as something closer to self-defense. You have to be rigorous with yourself precisely because no one else is in a position to catch what you miss inside your own reasoning. And if you slip, if you let one small, convenient assumption slide past unchallenged, it compounds. It becomes the foundation everything else is built on. And then you have a beautiful wooden airstrip. And no planes. This is why he was so suspicious of authority. Not of experts exactly, but of arguments that rested on the prestige of the person making them rather than the quality of the reasoning. He said, "Science is the belief in the ignorance of experts, not the dismissal of expertise, the belief that expertise earns you nothing unless you show your work, unless you remain perpetually willing to be wrong." And he was. He was willing to be wrong constantly. He said, "I can live with doubt and uncertainty and not knowing. I think it's much more interesting to live not knowing than to have answers which might be wrong." That is a rare kind of intellectual courage. Most people experience not knowing as failure. Feynman experienced it as the beginning of the only thing worth doing. The not knowing is where the understanding lives. Walk toward it. Always walk toward it. That was his whole operating principle. And it made him, in the deepest sense, the freest scientist who ever worked. And then there is the ending, the way a life closes, what it leaves behind.
Because Feynman's ending tells you everything about how he lived. By 1986, he was already sick. Renal cell carcinoma, a rare kidney cancer. He knew time was running out. And then the Challenger disaster happened, and something in him would not let it go. The space shuttle had broken apart 73 seconds after launch. 7 people were dead. NASA was in crisis, and the Rogers Commission was assembled to find out why. Feynman was appointed to it, an aging, ill Nobel laureate who had no patience left for institutional politics and never really had any to begin with.
What he found enraged him.
There was a gap between what NASA's engineers privately calculated as the probability of catastrophic failure, roughly 1 in 100 flights, and what NASA's management was presenting publicly, 1 in 100,000. That is not a rounding error. That is an organization that had learned to lie to itself. The exact thing he had spent his whole life warning against. And so he did what he always did. He went back to the thing itself, to physical reality, to nature, which cannot be fooled. In a live televised moment during the commission hearings, he took a small piece of O-ring rubber, the same material that had failed in the cold temperatures on the morning of the launch, and he placed it in a glass of ice water. He held it there. He squeezed it with a clamp. And then he removed it and showed the cameras that it did not immediately spring back to shape. It had lost its resilience. In the cold, the O-ring had lost its ability to seal the joint that caused the explosion. That was it. No mathematics, no jargon. 1 glass of ice water, 1 piece of rubber, 1 clear demonstration. He had cut through months of bureaucratic obfuscation with the same instinct he used as a 12-year-old in Queens, sitting quietly, reasoning about what the radio might be doing. His written conclusion, appended as a personal statement to the official Rogers Commission report, was devastating in its simplicity. For a successful technology, reality must take precedence over public relations, for nature cannot be fooled.
That sentence.
Read it again in your own mind. It is not just about rockets. It is a moral statement about the relationship between human beings and truth. You can manage perceptions. You can construct narratives. You can issue press releases. But the O-ring is still brittle in the cold. Nature is still there, unchanged, waiting. And eventually, the gap between your story and the real thing will close violently. That was the last great public act of his life. He went home, and he continued to fight his cancer, and he continued to teach, and he continued to be exactly who he had always been. James Glick, who wrote the definitive biography, described him near the end as still restless, still curious, still unable to let a problem sit unanswered. He refused dialysis in his final weeks. He is reported to have said, with characteristic dry humor, that he'd hate to die twice, that it was too boring. Even at the threshold, he was himself, unapologetic about the fact that he found unnecessary suffering tedious, that he preferred to meet the thing directly and honestly, rather than delay it with procedures. He died on February 15th, 1988, in Los Angeles. He was 69 years old. And then, someone went to his office at Caltech. Thank you for listening to the story of Richard Feynman. If you'd like more stories like this, make sure to subscribe and leave a comment on who you'd like to hear about next.